Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Um, Today we are looking at this question. It says, consider the transverse wave below. So this is the wave, and it says, from the diagram, identify the points that are in phase with B. Okay, let us first of all, what does in phase mean? In phase means those points which are exactly the same. Okay, let's look at what happens at B. A wave comes up and it curves down. Which other point resembles this? Okay, let us look at here. This wave is coming down and it's curving up. It's not the same as B. So let us go to F. What is happening at F? It's coming up and after that comes down. So this is the point. So the point which is in phase with B is F. Okay. Okay, let's look at another question. Yeah, then comes this one. A. Which points are exactly in phase with A? Okay, the question simply says, which points are exactly the same as A? So let us look at what happens at A. At A, the wave is going up. When you check at C, the wave is going down, so it's not the same. So A is exactly the same as E, because at E, the wave is going up. So the point is going to be C. Okay, even at J, what happens? The wave is going up. So E and D and J, those are the points which are in phase with A. So then comes this one. Which points are exactly in phase with C? Which, in other words, which points are exactly the same as C? What do we see at C? The wave reaches from top and goes down. And that point is G. So G is the point which is exactly in phase as C. Okay, then another question. Which points are exactly in phase as D? D is our point. What do we say at the point? It's the trough. The wave comes down, hit the spot, and goes up. So the point is going to be H. So those are the points which are in phase. And you need to remember that between two consecutive points or adjacent points which are in phase, that's where we have the wavelength. So remember, A and E, they are in phase and they are next to each other. So the distance from A to E is wavelength. B and F, they are in phase and they are next to each other. So the distance between B and F is wavelength. C and G, they are next to each other and they are in phase. So the distance between C and G is lambda. D and H are in phase and they are next to each other. So the distance between D and H is lambda. And that is that. So let's see what comes next. Okay. Then comes this question. It says, what is the term identified with each of the following length? Okay, BF. What is that length, BF? We have to know that BF, B and F are in phase and they are next to each other. So they represent wavelength. Okay. Let's look at AE. A and E, they are also in phase and next to each other. So they also represent wavelength. Okay. Then we come to X. What does X represent? X is the same as 8 centimeter. And what does 8 centimeter represent? It represents the amplitude. So that is that. Yeah, then comes this question. It says, what is the wavelength of the wave? Okay, when you look at here, we are going to note that D and E are in phase and they're next to each other. So the distance between them represents the wavelength, and that distance is 20 centimeters. So you can say 20 centimeters, or you can put it in meters as 20 divided by 100, giving you 0.2 meters. Okay, then what is the amplitude? The amplitude is the maximum displacement. So it's from here to the top, the crest, or from here to the bottom. So our amplitude is shown there, and it is 8 centimeter, or we can convert it to meters by dividing with 100. What you are going to get is going to be 0.08 meters. So those are the questions which have come from this. And remember, the channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard, here. Like we always do, don't forget to subscribe. We'll have to remind you that. And also to tap the like button. See you next time. Bye-bye.